When most of us think about stress, we think about it as a big, bad pathological entity. So here you see a slide from the National Library of Medicine that says stress is a loaded gun. It says if left untreated, stress can kill you just as surely as a bullet. Okay? And while this is with good reason, consider the following with me. Mother Nature did not give us a stress response in order to kill us. It gave us a stress response to help us survive. And so what do we mean by stress when we talk about it? Well, we define stress as a constellation of events that begins with a stressor. This is your stimulus. That then precipitates a reaction in the brain. This is stress perception. That then results in the activation of fight or flight systems in the body. This is your physiological stress response. An increase in heart rate, release of hormones like adrenaline, noradrenaline, cortisol. Very much like something that I'm experiencing right now, and maybe some of the other speakers have too. So most of us would agree that if a lion walked into this room, it would launch this kind of stress response and prepare us to fight or flee. But like I just alluded to, speaking at a TED conference like this also activates the same biological response, at least for most people, I would think. Think about this. Voluntarily getting on a treadmill or running around the beautiful streets of Vancouver or the beautiful parks here also activates the same biological response that the predator would activate that prepares you to fight or flee. And then getting a little more exotic, intensely excitatory stimuli, such as approaching someone for a kiss, maybe a first kiss, maybe when the kisser, the person approaching, is not very romantically experienced, also activates the same kind of biological stress response. In fact, sexual intercourse, is a potent activator of this response. What we also want to keep in mind for part of my talk today is that this response is potently activated during many medical procedures, such as vaccination, surgery, or even the process of drawing blood. This is actually my son getting his shots. And what you see here is a perfect example. The minute the needle goes in, it registers a full-blown psychophysiological stress response, as you can see from his face here. He's a little bit older now. So most research has focused on long-term stress. Okay, this is stress that we define as lasting for months to years in duration. And this is important. It's with good reason. But what we also believe is that it is very important to study short-term fight or flight stressors like the ones I was talking about. And we define those stressors as lasting for minutes to hours in duration. Okay? So one of the first questions we asked was, how does the immune system react during short-term stress? How do the body's defenses react during short-term stressors? And I'm going to summarize about 15 years worth of work for you here. Okay? So these little white dots are the body's defenders. Consider them as immune cells. They are the body's soldiers. And right here under resting conditions, I'm showing them lined up in the barracks. So organs like the spleen are the barracks of the body. The minute a stress response kicks in, within about 5 to 15 minutes, you see a large-scale mobilization. So the soldiers leave their barracks and enter the boulevards of the body, which is essentially our blood vessels. Their numbers go up in the bloodstream. As the stressor progresses, you now have a decrease in cell numbers in the bloodstream because their cells are leaving the blood and taking up positions at potential battle stations in the body. The soldiers are taking up positions in the skin, which is one example of a very important battle station, because think about it, most of the time if you're going to be wounded, it's going to be in the skin. The stress response not only sends more soldiers to defend battle stations, but it also activates them. So it increases their potency, it increases their ability to do the different kinds of defensive maneuvers that they are biologically capable of. What we have found is that the stress response activates the body's defenses even before there is wounding or infection. So the next question we ask is, does a short-term stress response during surgery, vaccination, or cancer therapy enhance immune function? And the answer we found so far is yes. So we found in studies that if you look at patients undergoing surgery, those patients who are capable of mounting a robust short-term stress response during the experience of surgery recover much faster and stronger than patients who do not mount that response. If you look at vaccination, if you couple a psychological stressor or a short bout of exercise before vaccinating an individual, you significantly enhance their vaccine responses. So I, for one, happily run around after my kids in the playground before they get their shots to try and sort of rev up the system as much as one can before they get the shot. And we are just beginning to look at the stress-induced enhancement of anti-cancer immunity and see if we can also harness this mechanism to enhance immune responses directed against tumors. What we want to do is maximally harness the biology of short-term stress during surgery, vaccination, and cancer therapy. So you may say, well, but how? How are you going to do that? Well, there are several ways. We have some idea about what stress hormones mediate what aspects of these different immune responses that I've just shown you. So one way to do it would be to sequentially administer these hormones to make different things happen. So that's one avenue. A short bout of exercise before certain procedures, such as a vaccination, could also help naturally maximize the response to the vaccine. And this is something that we are interested in. One of my dream stressors is using virtual reality as a stressor. Gaming, for example, but we haven't really been able to do much on that, but maybe there are members of the audiences here who might be able to help with that. And then there are manipulations of psychosocial stressors that would enable us to get this effect. So finally, just to give you something personal in terms of how we think about this, how do we reconcile these protective effects of good stress with the well-known harmful effects of bad stress? Okay? And here I want to present our idea of a stress spectrum. In the stress spectrum, at one end of the spectrum, you have short-term acute stressors, short-duration stressors. When you need the response, you mount it, and then you shut it down. At the other end of the spectrum, you have chronic long-term stressors. Okay, these are long-term stressors lasting for months to years. And in between, there's a very important zone of low stress. This is your zone of resting equilibrium. To maintain sort of good health, what you want is to minimize that bad chronic stress. You want to maximize your green zone, and you want to up the amplitude, ramp the amplitude, but minimize the duration of that good stress response. So how do you get there? Well, I don't have time to get into the specifics, but sleep, nutrition, exercise, and moderation. This is grandma's common sense advice, as well as calming activities. It could be meditation, it could be yoga, but it could be fishing, it could be bowling, whatever floats your boat, and other psychological factors we are working on that would help you get into this positive equilibrium. So our goals in an overall sense are to maximally harness the protective biology of short-term stress in a medical context to enhance responses to vaccines, surgery, and cancer therapy. But in a larger scale, what we also want to try to do is figure out ways to help people in general minimize their bad stress and maximize their zone of health and healing, which is represented by that yellow triangle and the green bar that I showed you in the previous slides. Thank you all for listening, and thanks to my collaborators too.